have spent a lot of my life moving between versions of myself: the gamer, the host, the producer, the editor, the researcher, the person trying to build something meaningful while also trying to keep up with tools that never stop changing. So when I walked into this NVIDIA back to school demo, I thought I was going to look at laptops through a practical lens. Can it handle games? Can it handle editing? Can it support student work? Can it keep up with AI? But what stood out to me was not just what the machines could do, it was how familiar the pressure felt. Students and creators are being asked to be more than one thing now: learn, make, perform, experiment, adapt, understand new technology almost in real time. The laptop used to be something you brought to class. Now it feels like something you bring your future into. But the setup was less about spec sheets and more about a question: what kind of work are these machines being asked to support? Gaming, video editing, AI tools, robotics, simulation, creative production, engineering, student work. Taken separately, each demo made sense. Together, they pointed somewhere larger. The back to school laptop is becoming a portable AI workstation, a creative studio, a gaming machine, a research tool, and an experimental space, all at once. That raises a bigger question then. Which laptop is best? What kind of life is this machine being designed for? And what does that say about the person expected to use it? Will Hugh is a rising senior at Harvard, double majoring in psychology and economics. He works full time in esports and creates VALORANT content. Before his RTX 50 series laptop, he was stuck between two bad options. His MacBook Air could not handle the full workflow, not the gaming, not Premiere, not the statistical software he needed for his coursework. His desktop had the power but was impossible to carry. His daily workflow: Premiere Pro for edits between classes, DaVinci Resolve for color and cuts, Valorant for content capture, RStudio and Strata for psychology and economics assignments, LM Studio tying his analytics together with local AI. One machine: student, creator, analyst, gamer, not in theory, in the same day. Halden Brutia is a third-year electrical engineering student at the University at Buffalo, co-project lead for the Mars Rover Club, and an engineering content creator on the side. His project is called Pseudo Arms, a low-cost teleoperation system for controlling robotic arms across planets. Before his RTX 50 series laptop, his MacBook M2 could not run the GPU simulation tools he needed. No CUDA support, CAD tools, limited or unsupported. That meant trips to campus just to use the lab PCs. In his demo, he ran Isaac Sim, NVIDIA's robotic simulation platform, directly on the laptop. A full digital twin of the entire system. A student who could not do this work at home can now develop, test, and demonstrate a complete robotic system from his own machine on his own schedule. The lab did not disappear. More of its capabilities can travel with the student. Siri Ural is a rising junior at Stanford, double majoring in economics and data science. She does research at the Hoover Institution and CSAC. Her demo was an AI investment flow tracker. It pulled public data on AI-related deals, chips, data centers, sovereign AI partnerships, classified them using a GPU-accelerated machine learning model, and managed the results as an animated graphic flow. She used NVIDIA's Rapids libraries to accelerate the data processing and model training directly on the laptop's GPU. Her use case sits outside of gaming and engineering, and that is the point. It shows the same hardware supporting a workflow closer to economics, policy research, and data journalism. The stations ran Resident Evil, Marvel Rivals, and 007 First Light across different configurations. The hardware is still built to perform, but the story has expanded. The same GPU architecture is now positioned for editing, data processing, machine learning, robotic simulations, and local AI. That showed up in student workflows crossing categories in real time. A back to school laptop is increasingly being asked to carry multiple kinds of serious work, and the demos reflected that rather than hiding from it. One of the quieter threads was local AI, which changes when some AI work happens on the device rather than only in the cloud. Will's offline analytics workflow was the clearest example, analyzing his own channel data using a model running entirely on the laptop's GPU. No internet required. It raises practical questions. When you are traveling, offline, or working with personal data, does having AI capability on the device change what is possible? Does it change what you feel comfortable feeding into it? Alison Vasquez, a senior AI systems software engineer at NVIDIA, described students being expected to manage models, agents, and creation tools directly, not just consume AI through a chat interface.
Particular for the student laptops, I think it's a great use case because it really gets students and like early creators just really hands-on with an environment that we could see being used for like everyday jobs in the tech industry. Students getting hands-on with a 5070, like the ability to have Windows, Linux, WSL, being able to run different projects and experiment with like different types of models for whatever use case, or like creation tools. These are things that we use every single day on the job. So just like having them be prepared to come in with those skills, it really kind of like positions them up to have like a really great first experience.
Local AI becomes part of AI literacy, understanding what runs where, the trade offs, and when cloud versus local makes sense. There are open questions around privacy, latency, cost, and control. The demo did not settle them, but it made the conversation feel less theoretical and more like something students and creators are already navigating. NVIDIA also had RTX Spark on display, a new category of slim laptops and small desktops built around the fusion of RTX graphics and AI expected this fall. NVIDIA is calling it a move from tool to teammate, machines designed for agents and AI workflows, not just traditional apps. In the context of this demo, RTX Spark felt less like a separate product announcement and more like a signal of where the whole category is heading. The same capabilities that showed up across Will's, Paladin's, and Series workflows are being built into the form factor itself. It is not a separate lane, it is the direction. I came into this asking a very normal question. What kind of laptops make sense for back to school? But I left thinking about something bigger. There's something strange about watching a laptop become a container for so many versions of a person: the student, the creator, the gamer, the coder, the researcher, the engineer testing a system she could not run at home a year ago, the person staring at AI tools and wondering if they are behind, ahead, or already inside something they do not fully understand yet. That is what stayed with me. Not just the machines, the quiet assumption that one person should move between all of these identities from one screen. The personal computer is starting to feel less like a tool for one part of your life and more like a place where all your identities collide. The details still matter, the trade offs still matter. Not every student needs the same configuration, and that is not about just more power, more specs, more upgrades, but the direction is worth paying attention to. Because it is not only about what the laptop can do, it is about what kind of person it is being built around and what kind of person we are being asked to become while using it. One machine, many selves. The personal computer is not just becoming more powerful, it is becoming more personal. And the question is no longer only, what can this machine do? It is, what are we becoming through it?